Hi, so in this video we're going to discuss some trigonometry with right triangles. So let's get to it. Okay, so here we have a right triangle, and notice that the right angle in the triangle is denoted by this square. And so in right triangle trigonometry, we name sides based on the angle we want to know or we know. So in this case, the angle here is denoted by theta. Let's write that over here. So this here is the Greek letter theta. Okay, so now we name the sides of this triangle based on their relationship to theta. So in this case, these legs, so the legs of this right triangle are the two sides that make up the right angle. So that'd be the side containing x and the side containing y. So in this case, the side that helps form the angle theta, that's the adjacent side. Okay. The side, the leg across the triangle from theta, that's the opposite side. And then no matter where theta is, the hypotenuse will always be the longest side of the triangle or the triangle opposite the 90-degree angle. And so in geometry, you learn that there are three trigonometric ratios that help us determine and solve triangles. So the first one is tangent. Tangent is always the ratio of the leg opposite the angle theta over the leg adjacent of theta. So opposite over adjacent. Sine is the ratio of the opposite leg from the angle theta over the hypotenuse. And cosine is the ratio of the adjacent leg over the hypotenuse. So we have this thing that's called SOHCAHTOA. This is a nice little way of remembering what sine is. So the first letter is the trig function, sine, cosine, tangent. And the two letters that follow it are the ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay? So that's one thing to know. Now down here we have some special equations that help us solve non-right triangles. So we can see that A, B, and C, those are the angles. So we can put angle B, angle C, angle A. So angles or vertices of triangles are always denoted with capital letters. And then the sides opposite those angles are lowercase letters. So the side opposite of capital A, of angle A, is little a. And so those are the legs. So in these triangles, in any triangle, the ratio of the sine of an angle divided by the length of the leg opposite is equal to any angle over its opposite leg. This is the law of sines. Okay? So as long as I have an angle and a side opposite that angle, I can solve a triangle. Now if I don't, so if I have an angle and the two legs that, or the two sides that create that angle, this is when I use the law of cosines. Now in Algebra 2, we don't really use these formulas that often. So they do come up periodically. And so we want to really know our trig ratios. So let's solve some problems with some triangles using trig ratios. Okay, so for each of these triangles, we're going to find the value of the missing variable. So in this triangle here, we want to find side and leg x. So when I solve triangles, what I think about is, okay, how is x related to what I know? So I'm given this length and this angle. So the angle is always going to be theta. Okay? And so the angle I'm given is related to the side. It's the side across from the angle, so I have the opposite side. And I'm given the other leg, which is opposite the 90-degree angle, so it's the hypotenuse. So I got to think about which trig function relates opposite hypotenuse. So let's write this up here. SOHCAHTOA. And so I'm looking at the two letters following S, C, or T. Opposite hypotenuse, what that looks like, that is so. That's sine. And so I'm going to set up my equation. So I know the sine of the angle, which is 15 degrees, is going to equal the opposite side, x, over the hypotenuse, which is 20. So I'm going to solve this for x. So x is going to equal 20 times the sine of 15 degrees. So I need my calculator. Okay, So, in my calculator, I'm going to turn this calculator on. So give me a second. Now, in my calculator, I got to make sure it's in degree mode. So I hit the mode button. And I got to come down here and make sure degrees is black. So I'm going to do that by selecting enter. Okay, so that's my calculator in degree mode. So now I'm going to go in my calculator. Can't see it right now, so it's going to be 20 times sine of 15. I hit the enter button. And I get 5.176. So I'm going to round this to be x equals about 5.78, and that's meters. Okay, so let's do this one now. We got the angle missing, but we got two sides. So this is theta. And so this leg here is the leg that creates the angle. So this is the adjacent side. And again, I have the side opposite the right angle, so it's hypotenuse. So looking at SOHCAHTOA, adjacent hypotenuse, well, that's cosine. So I'm going to use the cosine ratio to solve this. So I know cosine of the angle, which I don't know, is going to equal the adjacent side 10 over the hypotenuse 11. So because I don't know the angle, what I do is I use the inverse cosine. So I'm going to write it like this. So it's the cosine inverse of this ratio gives me angle theta. So my calculator, if you notice above the word cosine, it says cosine with a -1. That's the inverse cosine. So to get to it on this calculator, hit second cosine. And then in there, I'm going to type in the parentheses 10 divided by 11. And I hit enter. And I get 24.619. So we're going to round that. So this is 24.62 degrees. And so theta is approximately 24.62 degrees. Okay, let's do one more. This one. Now here I'm missing the hypotenuse. I'm not given an angle, but I'm given two side lengths. So in this case, I don't need trigonometry. I go to my good old friend, the Pythagorean theorem. So the Pythagorean theorem says the sum of the squares of the lengths of each leg of a right triangle is equal to the square of the hypotenuse. So we can name these. So let's let 12 be A. Let's let 6 be B. It doesn't matter which one's A or B, but the hypotenuse is always C in this equation. So I plug it in. So I get 12 squared plus 6 squared equals C squared. And so to solve for C, I'm going to square root both sides. So I get C is going to equal the square root of 12 squared plus 6 squared. So in my calculator, we're going to type that out. So we take the square root in the, we take the square root, it's the second root of 12 squared plus 6 squared. Close the parentheses, I hit enter, and it gives me approximately 13.416, so we're on to the 13.42, and so the length of C is approximately 13.42. I'm not given a unit of length, so it's just that. And so there are some examples of how to solve for missing angles and side lengths of right triangles.